Alright, so as I was saying, we're going to do some review first of things that we already know. So if I gave you this expression with a negative exponent, and I asked you to write this so that the exponent was positive, does anyone remember what to do with this? Emily? You make it look like a fraction, and then what? You put it in the denominator. Good. So remember, right now, even though this 3 to the negative second power doesn't look like a fraction, if we wanted it to be a fraction, it would technically be over 1, right? So it's in the numerator technically. Whenever you change a power from being in the numerator to denominator, or vice versa, you have to take the opposite of the exponent. So this exponent, the opposite of negative 2, is a positive 2. So we write it like this. Then what would that equal? What does 3 to the second power equal? 9. So this equals 1 over 9. 3 to the negative second power equals 1 over 9. All right? What if I had this expression, 5a cubed b to the negative second power? And once again, I wanted to write this so that I did not have any negative exponents. Emma? Very good. So remember, we need to think of this as being 3 separate things. We have the 5 by itself, we have the a to the third power by itself, and we have the b to the negative second power by itself. So because the 5 and the a to the third power have positive exponents, what's the exponent on the 5? A 1. So because they have positive exponents, the 5 and the a to the third stay on top, but your b goes to the bottom and the negative 2 becomes a positive 2. Remember doing that? And then this would be your final answer, okay? This would be simplified. All right, let's do one more of this type. If we had 7s to the 0 power, t to the negative 5th power, over 2 to the negative 1st power, m to the 2nd power. Why don't you attempt to simplify that on your own, and then we'll discuss it. Let me actually try to do this now. So when I look at this problem, kind of how I highlighted the 3 different things in the top problem, there's actually like 5 things I need to look at. The 7, the s, the t, the 2, and the m. Okay, I look at all of them separately. This 7 has a positive exponent, so the 7 gets to stay on top. My s has a 0 power, so this becomes the whole thing becomes a 1. And we don't really need to, again, show 7 times 1 because it's just 7. Okay, so it like goes away. T to the negative 5th, that means we're going to move t down to the bottom and it's going to become a positive 5, so that's taken care of. 2 to the negative 1st, because this exponent is negative, I need to move it up, which is going to change it to a positive 1, which we don't really need to write that positive 1 exponent, but I'm still going to. And then my m to the 2nd power is fine, so I'm going to leave it down at the bottom. So this is, Dawson, what you had exactly, right? Except the only other thing that we can do now is we can actually multiply our 7 and our 2 to get 14. And then technically this is right, this is fine in this order, but they do usually put letters in alphabetical order. So the best answer would be m to the 2nd power, t to the 5th power. But once again, it is not wrong listing t first. Okay, it's fine. Any questions about those? All right, so we did those like before we started I-step testing and all that wonderful stuff. All right, let's review another thing we did before we started testing. If I have the problem m to the 4th power times m to the 3rd power, what does that equal and how do you do it? What does that equal and how do you do it? Who's someone I haven't called on lately? Owen. I agree with m to the 7th. How'd you get to the 7? All right, so you add your exponents. Remember, if you as long as you have the same base, you must have the same base. You keep the base and you add the exponents. So keep your m, add your exponents, which this is not work that I expect you to show. You may obviously do that in your head, but I wanted to show it up here just so everyone sees it. And again, this will be posted on YouTube so you can see it on there. So now that you remember how to do it, let's say we have 10 to the 2nd power 12. 12 to the second power times 12 to the 8th power. What's that one going to be? Dawson. Good. So that's why all the time this throws people off when the base is a number. It is only when you have a coefficient, we'll do one of those in a minute, coefficient is a number in front of a variable, that's the only time you actually multiply. So again, the rule is keep your base, and your base is a 12, so keep your 12 and add your exponents, 2 plus 8. So 12 to the 10th power is your answer on that one. Keep in mind that if you have a base inside of parentheses, that it needs to stay inside of the parentheses. So if we had something like this, the base is a -5, it needs to stay in those parentheses. Gracie, what's our answer to that? Second power, good. 3 plus a -1 is 2. So -5 in parentheses, and then a 2. 3 plus a -1 is 2. All right, now let's do some that have coefficients. This is where you would actually multiply things. So again, a coefficient is a number in front of a variable. So the first thing that we would do is we would multiply our coefficients. 4 times 9 is 36. Our base is m. And then carefully, we're going to use our integer rules. 5 plus -12 is -7. Now let's write this answer so that we do not have any negative exponents. So remember, the 36 and the m to the -7 are two separate things. Is the 36 fine? 36 is fine. So 36 gets to stay on top. However, the m has to move down, and that becomes a +7. Let me have you try one on your own. Let's say we have 2a times 9b to the 4th times 3a squared. All right, anyone want to take some guesses on this one? Emily? Okay. Your guess? Okay. Anyone else? All right, so one thing that all three people have done, you're close, you're on the right track, okay? One thing that all people have done is remember that the coefficients get multiplied together, but it doesn't matter what the variable is for that coefficient. So that means that the 2, the 9, and the 3 get to be multiplied together. So even though this 9 has a different variable next to it, those can still be multiplied together, okay? Now we can't combine our a's with our b's, but we can multiply our coefficients still. So 2 times 9 times 3, I would probably do commutative property. 2 times 3 is 6, and 9 times 6, 54, okay? Then remember, it's proper form to do alphabetical order, so A comes before B. And if I add up my exponents for A, this is really a 1, remember, so 1 plus 2, so A to the 3rd. Several of you said that. There's nothing to combine with B, so B stays B to the 4th power. Nothing is negative, so it's all good. Questions on that one? Yes, ma'am. Yes. Okay. All right, now let's get into some newer stuff. So that was kind of a review of things that you already knew. Okay. Let me make sure I make a slide. So the first thing that we're going to do is we're going to raise a power to a power. So raising a power to a power. And again, this is new stuff. If we had m to the 6th power in parentheses and then I had this whole thing to the 8th power. Have you ever seen anything like that? Some people said yes, some people said no. All right, this is when we actually do multiply the exponents. So what we're going to do here is we're going to keep our m, and we're going to do 6 times 8, which is 48. And that is our answer. So now if you see it on star, you'll know, right? So if my base is a 5, 5 to the 4th power, and that whole thing raised to the 2nd power, what would it be now? 5 to the 8th power, 5 to the 8th power. 4 times 2, so it'd be 5 to the 8th power. No, so we're not going to work out 5 times 5 times 5 times 5, all right? Our base, technically, but then you'd have to simplify it back down using prime factorization. We don't want to have to do any extra steps unnecessary. So even when your base is a number, just keep your base the same, okay? Don't multiply your bases together. Now we saw some in previous lessons, and I told you actually to skip over them, where our exponents were fractions. So if we see those fractions, like let's say we have x to the 2/3 power, and I raise this whole thing to the 1/2 power. This looks like it'd be horribly confusing. But remember what the rule is. The rule is keep your base and multiply the exponents. So if we keep the x, and we're going to do 2/3 times 1/2. And you know, even if you're not very good with fractions, which most people in here are, it's not an issue, but remember with multiplying fractions, you just multiply straight across, and then you want to simplify if you can. So Emma, what is this? Very good. I'm going to go ahead and write x to the 2/6, and then I'm going to simplify it down just so I have it in our notes nice and clear. And I'm going to put a little star that says simplify. I try not to do too many mental steps up here in notes, again, just so you can look back at it and know exactly what was done. So does that make sense there, how we did that? So again, it looks like it's going to be horribly confusing, but it's really not that bad. Alright, if we get that, then let's move on from there, and we're going to kind of combine the things that we reviewed with this new concept, okay? So let's say we have y to the 3rd power, and then in parentheses, I have y to the 5/2 power, and that to the -2 power. Okay. So you can see this has gotten more complicated now. So we're going to do this in 2 basic steps. The first thing that we want to do is kind of like the skill that we just learned. We want to focus on this first, okay? So just leave your y to the 3rd power hanging out for a little bit. It can just stay over here, okay? We're not going to do that until the second step. So let's go ahead and do 5/2 times -2. How do you do a fraction times a whole number? That's right. So we're going to make it a -2/1. So this is going to become, some of you know shortcuts, right, to multiply fractions. 5 times -2 is -10/2, which then becomes -5. Again, those of you that know shortcuts, that becomes much quicker for you. So this becomes y. Actually, that parentheses here now can just mean multiplying. We're doing the y3 times that thing, which is y to the -5th power. All right, well, yeah, so hold on. So let's make sure everyone's okay with how I got y to the -5th power. So now we're on to this step down here. So this is the step that's similar to how we were reviewing. When we are multiplying and we have the same base, my base is y, you keep your base and you do what to your exponents? You add them. So we're doing 3 plus -5. So again, this is something that a lot of you could do 3 plus -5 in your head. Others of you, it's helpful to actually see it. So you make the decision whether it's something that you want to work out or not. So this is y to the -2 And if we want to write this so that it's only a positive exponent, the final answer would look like... So the y is your base. Remember, that has to be moved down then. So 1 over y to the second power would be our final answer for this problem. You'll want to simplify it so that you don't have any negative exponents, yes. Okay. This one is kind of similar. Why don't you try this one on your own then? So x to the second power times x to the sixth power to the negative fourth power. So let me work that out up here. This right here, we're just going to wait until our second step to do anything with that x squared. Over here, I'm going to go ahead and do my 6 times negative 4, which equals a negative 24. So that's going to give me x to the negative 24th power. And then my next step would be to keep my base, x, and add my exponents, 2 plus negative 24. That gives me x to the negative 22nd power. And we want to end our answer with only positive exponents, so I'm going to move that to my denominator position. There it is. 1 over x to the 22nd power. I know. Alright. M to the negative 5th times a negative 1/2. Okay, m to the negative 5th times a negative 1/2. And then multiply that times m to the 3 over 2, 3/2. So remember, do your power to a power thing first, and then do your product to powers rules. I'm going to pause this and you can try. Alright, so for those of you that did not get m to the 4th power, let's see how we get that. Okay, let's see where you went wrong. So again, this is what we need to do first. We need to do negative 5 times a negative 1/2. So this is like a negative 5 over 1 times a 1/2. Negative times negative is a positive, so that's going to give me m and then a 5 over 2. Okay? That's what we should have gotten for our first step. Taking that times m to the 3 over 2. Now, our rule here is keep the base and add the exponents. So keep your m, and you need to do 5 over 2 plus 3 over 2. Leave them improper, it's fine. We'll simplify at the end. 5 over 2 plus 3 over 2 is 8 over 2. And now it's time to simplify. 8 over 2 equals 4, so m to the 4th power. Questions? Yes. Okay, so now we're going to get into simplifying, and simplifying is the only difference is, again, instead of just having one base, like m only, you're going to have other bases in there as well, other powers, okay? So don't worry, we're going to start off somewhat easy. Alright, we had something like this. 7m to the 9th power, and then that raised to the 3rd power. I want you to think of this kind of like the distributive property, okay? But what we are distributing is this power out here, okay? We're going to distribute this power, this exponent, to the 7, and we're going to distribute it to the m to the 9th power, okay? So it's like two separate things here. Again, we want to think of your coefficient and your base with the exponent as separate things. So this is going to be the same thing as 7 to the 3rd power and m to the 9th to the 3rd power. Okay? So again, I just distributed that, for lack of a better term, distributed that 3 to the 7 and to the m to the 9th. We okay with that? Alright, now, I know I said that you didn't need a calculator, so I will do this for you, but you would want to go ahead and work out 7 to the 3rd power. So we all know that's 7 times 7 times 7, and that equals 343. Okay, so when you have to do that on your own, you can get a calculator. It's not going to be a big deal. Let's now look at our m to the 9th to the 3rd power. What do we do with that again? Multiply them. So we're going to do 9 times 3. So yes, m to the 27th power, and you're finished. Not too bad, right? This all looks way worse than it is, but also keep in mind, this is definitely one of those things that when we do it together, it seems like a piece of cake, and then you get it in front of you, and it's like, oh my gosh, what do I do? Okay? So, and I completely understand that. Even, like, I wrote these notes 2 days ago, so right before you guys came in, I reviewed it, because just glancing at it, I was like, oh my gosh, what did I do? But then once I got into it, I was like, oh yeah, I remember. So keep in mind, that's one of the reasons I post these notes on YouTube. You're here today, but you can still go back and watch it and get to the part that you're having trouble with, and hopefully that's why you take good notes as well. Because a lot of times just glancing at it helps you remember what we did. Okay, let's do another one. 2z to the negative fourth power. So again, that negative fourth is going to be distributed to the 2 and to the z. Okay? So if we think about what 2 to the negative fourth power is, and what z to the negative fourth power is, we want to end this with only positive exponents, and we also want to end this so that our numbers, any numbers, bases that are numbers, we want to go ahead and multiply them out. So first of all, how would you write this as, so it doesn't have any negative exponents? We put it underneath, right, in the denominator. So we could have actually done that here in the beginning. We could have rewritten this whole problem, 2z on the bottom, and then changed that 4, or a negative 4 to a positive 4. We could have done that to start with, but we still kind of ended up with the same thing, okay? That we're doing 2 to the fourth power on bottom, z to the fourth power on bottom. Again, it's ending up the same thing. So it doesn't really matter if you change that 4 to positive first, or if we did it like this. Does everyone understand what I did here, though? All right, okay. So really the only other thing that we have left to do with this problem is to figure out what is 2 to the fourth power. Does anyone just know that? Oh, 16, good. So this is going to be 16. So I'm going to have 1 over 16z to the fourth power. That's it. All right, you ready to try one now? Okay, here we go. 3g to the fourth power, and all of that to the negative second power. That's not one that you're going to need a calculator for. Figure it out. So, again, we could rewrite this right now so that we have a positive 2 out there. Okay? And then we are distributing that 2, so 3 to the second power, g to the fourth to the second power. So 3 to the second power equals 9, and g to the fourth to the second power, that'd be 4 times 2, which is 8. I don't know why I wrote what I did. All right, so that's going to then finally give us well, I'm going to blame Xander on that. That's going to give me a 9, so 3 to the second power is 9, and then g to the 4 times 2, that's g to the 8th power. I know, right? So obviously we'll do the assignment tomorrow, and that's fine. No, but we're not done. You're not going to have any homework, so don't worry. Okay, let's amp. This is the last little bump that I'm going to amp it up, okay? This is it. Here we go. Okay. It's going to be okay. It's going to be okay. Yeah, it is. All right. So, again, my advice to you when it comes to these problems is when you look at the whole thing, it's overwhelming. You need to break it into pieces that you can do. All right? So, before we do anything else over on the right-hand side, let's just focus on this right here. How would I figure out this? You just multiply it, right? Now, I would distribute it if there was a coefficient, but there's no coefficient. So I'm just going to do 1/2 times 10, which is 5. 1/2 times 10 is, half of 10 is 5. So this is just going to be n to the 5th power. Now that wasn't bad, right? Good. All right, now let's work on our other side. So we're going to forget about this n to the 5th power for a little bit. This is where I do that distributive. I need to say 4 to the 3rd power. I need to say m to the 3rd power. Because, hold on, there I had a question, I think. Okay, so 4 to the 3rd power, m to the 3rd power, and then I need to do n, and that's going to be -2/3 times 3. So I'm going to focus on each one of these separately. 4 to the 3rd power means 4 times 4 times 4. That's 16 times 4, which is 64. I'm just going to kind of put multiplication signs in between all my things here. M to the 3rd, there's nothing to do there. Now, let's think about this. -2/3 times 3. First of all, is it going to be positive or negative? Negative, because different signs, negative. -2, right? Because it would be -6/3, which is 2. The easiest thing is using cross reducing and getting rid of those 3's, right? Okay, we're almost done then. Okay, now we're going to kind of organize this. I have basically 4 things up here. This n to the 5th, the 64, m to the 3rd, n to the 2nd. Organize it. First thing, you don't list your letters before your numbers. So the 64 has to be listed first. So that's taken care of. We can kind of mark it off our list. Okay? Next, alphabetical order, m comes before n. So m to the 3rd would be next. So that's done. Mark it off our list. Now our n, we have 2 of those. So we need to do 5. That's right. We need to do 5 plus a -2. I'm sorry. Anywho. All right. So our n, 5 plus a -2 is a +3. And there we have it. Okay?